We're going to be building on the last episode with moving averages by, instead of just trading when prices are above a moving average that we define, we're going to be doing a crossover strategy. So we can look at a couple other variants of our last study to make sure that we don't see anything that we might be missing. 20, 200, none of it works. So what if we're just using moving averages incorrectly? Most of the time, people, when they use moving averages to create a strategy, there are at least two. So that's what we're going to do today. We're going to add a second one, and we're going to see when the fast one crosses over the slow one, then that is going to be an upwards trend, and the opposite when the fast moving average is below the slow moving average. So it'll be trend following, or some people call it swing trading. Just a different way of defining a trend, so a little bit more complex, and we're going to build on top of that. In the episode after this, we're going to be moving the moving average convergence divergence. So our first formal technical indicator will be coming up soon, but first we have to understand how to make multiple moving averages and how to get them to interact with one another. So we're going to define a global variable to separate the two moving averages. So one's going to be fast and one's going to be slow. And those are going to be the rolling windows that we use to define those moving averages. So one of them is going to be a 10-day moving average, and the other one will be a 27-day moving average. We can change the time period, so instead of days, it's hours or even 5 minutes with Yahoo Finance, but the quicker the time frame, the less data there is to work with. So I like working with daily and hourly data simply because there's more to it. And the truth is, if it doesn't work on one of these time frames, it's probably not going to work in a different one. The random behavior of share prices it extends to all time intervals. So if you don't see something on daily, it's super unlikely you're going to see something on minutely or hourly. If you don't have a good strategy, it won't work on any time period, just how it is. So what are we going to do? We're going to, instead of doing the 3-step process, we're making a 4th step for adding moving averages. We're going to make this a 4-step process for adding extra data, and it's going to be adding the fast moving average and the slow moving average using what are called F strings in Python. So this, you can use F strings and put them in the little brackets, the global variables, to change the name of them dynamically. So now you can see that we're calling fast and slow. So whatever it is, the name of the column will follow what we define it as before running the function. So we're defining fast and slow moving average columns based on the rolling fast and slow lengths to assess a crossover strategy. And we're going to return the data frame with those two extra columns. All right, so that all looks good. So let's get rid of the bottom couple functions from the last period, put those in a separate cell, and then just run these two to see what we end up with at the beginning of our study. So df is get the data of the ticker, and then we're going to add the moving averages afterwards. And those moving averages are going to be of the fast and slow lengths that we define in the global variables before running the whole function. And there it is. We have our 10 moving average column and our 27-day moving average column. Again, it can be hours, but we are doing days for now. From last episode, make sure you have these packages installed. You can run this code in your virtual environment. Pip install matplotlib, pandas, yfinance, and numpy. I already have these installed globally and within this virtual environment, so I'm going to get a different output than you are if you run those. And then we import all of these packages using these lines here. So let's import pandas as PD just to be safe. So now we want to plot some of these moving averages to show you guys what's going on. So once we have the data frame defined, I'm going to make a plotting script to make a quick graph of what we're working with to show you what our trading strategy is going to be doing. So matplotlib.pyplot is a great way to visualize any of your trading strategies before you decide how to define them. So I use these to get a better understanding of what's going on, and this is going to be the code for that. just like with the moving averages, we have to call in the columns dynamically, so it always references those global variables. And there it is. We now have the fast and slow moving averages plotted there. Let's on top of it plot the... Actually, so let's take a subsection of the data frame using iLoc or iLoc. Either one works. iLoc is used to parse a data frame based on its rows and columns. So all rows would be denoted as a colon, and all columns would be denoted as a colon as well. So, but for example, if you wanted all rows and all columns, you would just write this. You can change how many rows you want to see or how many columns you want to see. So say we want the last 100 rows. We'll go to negative 100, and then the colon is going to take us onwards to the very end of the data frame. So now we just see the last 100 rows of that data frame, or the last 100 days. So now we're just going to plot the subsection, or the last 100 days of the data frame, of the closing price, the fast moving average, and the slow moving average, and there it is. Looks pretty great. So from here we can see a general strategy. Let's add a legend to make this chart more beautiful, more understandable. This is my data science perfectionism showing up. Chart without a legend. It's no good. And we make the legend the same order as the plot orders we made, so it stays indexed correctly. Make sure you don't make the same mistake I have made several times. And there it is. So the green line is the slow moving average, the orange one is the fast one, and the blue line is the close price. And you can see immediately when the orange line crosses below the green line, it looks like we might be able to see a good trading strategy where after that crossover happens, the prices continue to trend downwards. So, did we do it? Does it work? We're going to find out very soon. And then we're going to add a title, moving average crossovers, and there we have it, a beautiful chart. Let's look at the last 300 days just to get a better understanding of the bigger picture. And we can do 500, 1,000, 10,000, whatever you want. That's the benefit of creating a subsection. And then, so from there, it's time to add our strategy. And what is our strategy going to be? We're going to go long when the fast is above the slow, and short in the opposite environment. So let's get started with programming that. I want to add this plot to the addition of the moving averages so we can always see the data that we have available. And we can add a look back. So instead of creating a subsection within that function, we can just define a look back globally, so we're always working with our desired amount of days to study. So we're going to initially set that to be none. So there's no limit on how far back we're looking. So our subset is going to be a unlimited look back of data, and then all of the rows. I'll write a little note denoted by that hashtag, taking a chunk for plotting. And then instead of the data frame, we're going to be plotting just a subset of it each time based on our desired look back window. And if we run this, and if we go ahead and run this, oh, okay, there's an error with none type because I indexed using none, so that doesn't work. I thought it might. So we're just going to use a really big number to take the maximum amount of data we can. I said 10,000, and so that gives you 30 years of data, which is great. We can do 100 to see that chart, so it works perfectly fine. Now we can see the number of days backwards that we want to see based on just changing the number here. Now, you might have been backtesting manually, and you would have to go back one by one by one by one, and the further back you wanted to look, the longer you would have to take. With this, now that you know how to code, you can see that you just have to change the number. It can be 100, it can be 1,000, and it can take you the same amount of time. That's really powerful. So just understanding this really basic code, it might not seem basic at first, but we're gonna keep building on it until it gets to a really complex level. Just understanding this basic level of code, you can understand already how powerful this is when you are competing in the trading space. Can you imagine testing all of these crossovers manually? It would take you weeks, but we've already done it, or we're going to do it right here in 20 minutes, and you're already going to be hundreds of miles ahead just by the end of this episode. Now it's time to define the strategy. So we are again going to use np.where to define where we want to change our behavior. And so our behavior is going to change when the moving averages change structure. So when the fast moving average is above the slow one, we're taking a long position, and when the fast moving average is below it, we're taking a short position. So np.where that happens, we go long, otherwise -1, we go short. So that way we can just multiply the cumulative returns of the asset by the strategy signal. And it's a very simple strategy and a simple way of calculating it too. If you don't quite get it yet, you'll start to see a pattern as we continue building these strategies. You load in the data, you define the strategy, so when you want to be long, when you want to be short, and then you multiply those signals by the cumulative returns of the assets, and you just plot them. So that's how I test and trade my strategies. Then just going with what you can see with your hands and eyes on a trading view account for free. It's like fighting a swordsman with a toothpick. Now you have the sword. Awesome. So we can see our strategy has ones and -1s based on whether or not the moving average is higher or lower. Great. So we're almost all the way done. The testing is done by multiplying the asset returns, or the cumulative returns of the asset, by the cumulative returns of the strategy, which you get by multiplying the strategy signals by the asset cumulative returns. So how do we get the cumulative returns? We use NumPy. NumPy has a cumprod function which can give you the cumulative product of the close price percent changes. And that looks like this long line here that we're going to write. np.close percent change. And percent change is a function, so we got to change this to here. Awesome. And I think I put cumprod in the wrong place. I'll fix that later. Let's first do df strategy returns is going to equal pretty much the same thing, just multiply that by our strategy column. And yep, I did use cumprod incorrectly, so it changed notation a little bit. I have to move it to the end.cumprod, and it is a function, so we're going to do the same thing with this line. And from here, we should be all set. So let's add this test strategy function to our haphazard main function at the bottom of our cell and see how it goes. So super important here is that we shift back the strategy signal. So if we don't do this important shift, it's going to give us the signal the day that crossover occurs. The issue is, or the period that crossover occurs. And the issue is we don't know whether or not that crossover will happen until after it has happened. So we need to shift the signal back the period following the instance of that crossover. So another way of saying that is, if you don't shift it backwards, you would already know that the close price will be higher than the moving average at the end of the day, before that actually happens if you are using the raw information. But you can't. It's impossible. So we only know close price crossed over the moving average after the share price closes. So we need to take that the following day or the following period. And if you don't do that, you will get highly inflated returns if you forget to shift everything back. So this is our final data frame. We have the 10-day moving average, the 27-day moving average, the strategy where we're long or short based on their comparative values, asset returns, and strategy returns. So there it is. That's the whole test. But we can plot it just to show you guys what this looks like. So we're going to go back to matplotlib to see if we can plot some of the returns from our strategies. We're going to paste in, I think, some of the code from above. Yeah, let's take that subset section here. And this isn't quite as efficient as it could be. We're going to change this a little later, but for now, let's see. Let's just do this. And now our legend is going to go asset returns, strategy returns. And I'm going to do an F string to include the ticker that we define globally. So every time we regenerate the chart, it changes the ticker automatically. And just for good practice, I'm going to put the ticker in like this, lowercase, as it is an argument instead of a global variable. I understand that terminology might not be super familiar, but it's still good to hear as you are learning. And then the last thing on our legend is going to be an F string with two inputs, the short and the long. So we're going to add those as arguments to our function. Short and long, crossover strategy, fast, slow. I don't know why I keep writing short and long when I define the global variables as fast and slow. We're going to fix that one more time, fast. Those terms are sort of used interchangeably when talking about moving averages, and this plot does not look right at all because we need to add plot plt.figure to make sure that Jupyter shows us a second plot. Great, now we have two, but that still does not look right. And it is because I defined subset twice, and it is just showing me the final results of this strategy. So it's a little bit of a spoiler. These are the last 100 columns of the cumulative returns, so they don't start from the same period. But if we redefine subset and we put that at the very top, we can change the way these plots look to always start from the same starting point at the beginning of our desired look back period. So let's change this. Let's get rid of subsets within these functions. No more subset. And just change the subset into the data acquisition part. So it's always mentioned, it's always correct when we run the whole main function or the haphazard main function that we had. So return the look back subset of our data frame when we are acquiring the data in the first place. Only return the subset of data that you are interested in. Great. And change that to data frame as well because we're already working with the subset. And if we run all of this, we should see a much better plot for cumulative returns, and we do. And look, it looks like our crossover strategy does outperform over the course of our 100-day look-back period. But now that we have the ability to just change our look-back period with the click of a button, let's do 500 days instead of 100. Zoom out a little bit. Run this using run all here. Okay, we're not quite above anymore. It looks like we're starting to flatten out a little bit. But what if we go even further back? Let's go all the way out 1,000 days. Get rid of window. That's from our old code. Let's do 1,000. Yep. Run it. Okay, it looks like it's getting a little worse. Delete the pasted version of our old code. But what happens when we just run the whole thing? Let's do 10,000 days. Every single possible piece of information from Yahoo Finance for free. Bump this up to 10K. It's going to be 30 years. And there we have it. It is really bad. It does not work at all. But again, these strategies are still simple. And while I didn't expect it to work, you might be under the impression that crossover strategies can provide an edge. It looks like it when you test really temporarily, but when you zoom out, which you now have the ability to do using code, it's pretty obvious that it is not a very effective way of trading. We can tailor these values however you want, and I encourage you to do as many as you want. And heads up, I have tested programmatically every single combination before, and none of them work. But we're going to keep building on this in later episodes, and I encourage you to follow along, copy this code yourself, and we can keep making a really advanced trading strategy using code pretty soon. But as you can see, everything we've done so far is already miles ahead of anything you might have been able to do just using your hands and laptop. So congratulations. I'll see you in the next episode.